Alright, section 5.3 for our advanced algebra chapter is going to be adding, subtracting, and multiplying polynomials together. We're going to really focus on how to do all of those processes. So to add and subtract polynomials, all you guys are going to do is add and subtract the coefficients of like terms. Now, like terms are slightly different this time around than they have been in the past. So if we consider like x squared, and x to the fifth. Before, when we talked about like terms, you basically just were matching up x's with x's, y's with y's, z's with z's, so on and so forth. Well, now we really have to be cognizant of the degrees of which all of our terms have. So x squared and x squared are like terms, where x to the fifth is not a like term with those other two. So to add and subtract these, we have a 4-term polynomial plus a 3-term polynomial in example number 1. If it's just adding, you can go ahead and put like an imaginary 1 in front of the parentheses to kind of make this process a little bit easier for yourself. So you're really distributing like a 1 into the parentheses. Now I'm doing this so that I can basically get rid of the set of parentheses. Some people see those and they freak out and they don't really know what to do, and they start multiplying the two things all together, and you don't want to do that. So I go ahead and I kind of imagine that there's an imaginary 1 out in front of the set of parentheses, and I distribute it into all the pieces. Getting that gets me to a problem that it's just one string of terms, and it's a little easier sometimes to go ahead and see which like terms you should be combining. And again, like we said, all we're going to do is add and subtract the coefficients of those like terms. So we have 2x cubed and a positive x cubed, which will give us 3x cubed. Negative 5x squared. Positive 6x squared is going to give me a positive 1x squared. You don't really need the 1. Positive 3x, you don't have any other like terms, so it's just going to remain positive 3x. And we have negative 9 and positive 11, which combine for a positive 2. Really pay attention to the signs that are associated with those coefficients. Alright, so that's one way to do this, where you're really kind of distributing a 1 into the problem. I personally don't do that on most of them. I try to shorten it up, and I just pay attention to the sign that's in between the two polynomials, in between the two sets of parentheses. In this case, it's addition. So what I like to do is I basically look for the like terms in the sets of parentheses, and I just combine them. So 3y cubed is going to add to any y cubes in the other one, but there aren't any. So it's just 3y cubed. And negative 2y squared, I'm going to add it, because we have the addition, to the negative 4y squared, which gives me negative 6y squared. Negative 2 plus negative 4, negative 6y squared. And I'm basically moving down the line. So I started with the highest degree, which was y cubed, and then I took care of all my y squareds. Now I'm going to do my y's. Negative 7y plus 2, so it's plus a positive 2, so it's just going to be negative 5y. And then I have a negative 5 left over. So it's nothing plus negative 5, which remains negative 5. That's the way I kind of do this, so I don't really sit there and rewrite the whole thing. Try it both ways, right? And whatever way kind of works for you. So we'll do another example here, but this time we'll do it with subtraction. We'll do it both of those two ways. So we'll distribute a 1 into it, and then we'll do it the other way. It's a little shorter. A little more prone to make mistakes, though, on the second way. So the first way, we're going to put a 1 out in front of the parentheses, and we're going to distribute it in so that we rewrite it. So my first polynomial turns into 3x cubed plus 2x squared minus x plus 7. But this other one, you got to be really careful on, because really we're distributing a negative 1 into everything, and that's where people make some mistakes. You have to distribute the negative into that second set of parentheses. So then we're left with negative 8x cubed. We're going to have positive x squared, positive 5x, and negative 1. From there, all we're doing is combining our like terms. So we'll combine the x cubes and get negative 5x cubed. We'll combine our x squareds, and we'll have positive 3x squared. Combine your x's, we have a negative x and a positive 5x. Give us positive 4x. And then 7 and a negative 1 will leave us with a positive 6. I like combining them starting with the highest degree first, because then my answer is already written in standard form. I don't have to move anything around afterwards. So let's look at that second example now. And again, this one I'm going to do kind of the shorter way, the way that I tend to do these. I just circle the sign that's in between, and then I'm combining terms while paying attention to that sign. So I start with my highest degree, which is z squared. So it's going to be 5z squared minus 4z squared. So it's just 1z squared. And then I have a negative z minus positive 9. I always got to really, really pay attention to that sign in the middle. So I'm basically like rewriting it all, but I'm kind of doing it in my head a little bit. So negative z minus 9 is going to give me negative 10z. And then I have 3 minus the negative 12. Minus a negative is really going to be addition, so it's going to be plus 15. A little less work, a little bit more in your head, a lot more prone to make mistakes with that method. But I figured if I do it, I might as well show you guys too. Some of you might catch on to that a little easier. All right, next we're going to move into the multiplication aspect. When you multiply each term of the first by each term of the second. Really, you're distributing everything that's in the first set to everything in the second one. Make sure you're doing each term to each term, right? So that negative 2y squared has to get multiplied to both those pieces. The 3y has to get multiplied to both those pieces, and the negative 6. So we'll start with the negative 2y squared. When I distribute it to the y, I get negative 2y cubed, and negative 2 times negative 2 is going to give me positive 4y squared. Now I'm going to go ahead and distribute the 3y. I'll be left with positive 3y squared, and distribute it to the negative 2, which will give me negative 6y. And I have to also make sure I distribute the negative 6. Negative 6 times y is negative 6y, and negative 6 times negative 2 is positive 12. Now we're not done with our answer there. We actually have to take it one extra piece, right? And we're going to go ahead and combine our like terms. So we are left with negative 2y cubed. The y squareds will leave me with positive 7y squared. Another habit, right, that I form that could be very useful for you. When I have a very long string of numbers and a long string of terms, I like to cross them off as I combine them. That way I don't miss anything. Sometimes you'll find that you think you combined all your like terms, but then all of a sudden there's a y squared at the very end of the problem that you forgot about. So crossing them off as I combine them, I feel like has helped me make sure that I don't miss a term. So we'll go back and we'll keep combining. My negative 6y is combined to give me negative 12y, and I'm left with still the positive 12 that doesn't combine with anything. Number 2, we have a binomial times a trinomial. So make sure you distribute the x to everything and the positive 3 to everything. So when I start with the x times 3x squared will give me 3x cubed. X times negative 2x will give me negative 2x squared. And the x times the 4 will just give me 4x. Now I'm going to go ahead and distribute the 3. So I get positive 9x squared. I get negative 6x when I distribute it to the negative 2x. And 3 times 4 is 12. We're going to go back and combine all our like terms, starting with the x cubes. Negative 2x squared and positive 9 will give me 7x squared. Positive 4x, negative 6x is going to give me negative 2x. And I still have a positive 12 at the end of the problem. We've used all our terms, so that would be our finalized answer. And last but not least, 3 separate polynomials that you're multiplying together. This one I see so many mistakes on. You really got to be careful about these ones because a lot of people try to just distribute everything out, and you make some mistakes with it. So let's go ahead and kind of run through what we're going to do. We're going to take the first two, x minus 5 and x plus 1. We're going to multiply those ones first. We're really going to kind of pretend that x plus 3 isn't even part of the problem. We'll come back to it later. So for right now, if I just had x minus 5 and x plus 1, we're going to distribute everything in the x minus 5, so both the x and the negative 5, to both the terms in the second one. That would leave us with x squared plus x minus 5x and minus 5. really we just kind of distributed, right? You guys might think of that as foiling, but you're just distributing. Combine your like terms, and you're left with x squared. You can combine those two middle terms to give us negative 4x minus 5. So that's really us taking those first two pieces and multiplying those together. But don't forget, you also had that x plus 3, so now we're going to bring it back into the problem. And we're going to say, okay, well, the result from x minus 5 times x plus 1, now let's go ahead and multiply that by that x plus 3, that third missing piece. And now the problem looks exactly like the previous ones, right? Distribute the x squared, then the negative 4x, then the negative 5. So we're left with x squared minus 3x squared after I distribute the first term. Now we're going to distribute the negative 4x to both. And we're left with negative 4x squared and negative 12x. And after that, we're going to go ahead and distribute the negative 5 to both those pieces. So we have negative 5x and negative 15. We're going to take it one last piece and combine all our like terms. So x cubed is by itself. We have negative x squared when I combine my two x squared terms. We have negative 17x when we combine those two terms. And we're left with negative 15 at the very end of the problem. And that's our final answer. Or if you go back, a lot of people kind of question that one and they say, wait a second, why did you do that? And what mistakes do I typically see when people are doing this problem? Well, here's a couple of them, right? I see people take and they multiply that x, but then they distribute it to the other term as well, and they get a whole bunch of different x squareds going on, right? They get x squared and then the other x squared, and you can't distribute one set, the first set of parentheses, to both the other sets of parentheses. We don't want to do that. It might make sense if we use a number aspect to this. A lot of people go ahead and say, oh, it's x times x times x, and you're going to get x cubed. Don't fall into that trap, okay? Let's consider numbers here, right? So instead of x minus 5, x plus 1, and x plus 3, to kind of illustrate what I mean by this, if I asked you guys to multiply 3 times 2 times 5, hopefully right now in your head, you can think, what is 3 times 2 times 5? And you're sitting there and you come up with 30. Hopefully it was 30. And if I said, how did you get it? Well, you should hopefully have done 3 times 2, which is 6, and then 6 times 5, which is 30. So the problem that I see sometimes, right, the mistake that I was talking about when people distribute that first term to both the other terms, they did x minus 5 and they multiplied it to the x plus 1, and then they did x minus 5 to the x plus 3, and they're over distributing, would be like if somebody took 3 times 2 times 5 and they said, oh, 3 times 2 is 6 and 3 times 5 is 15. And then 6 times 15 is really not 30 at all. It's going to be much larger. It's 90. Well, the answer is not 90. We know that 3 times 2 times 5 is not 90. It's 30. So that's kind of that illustrate that mistake a little bit. You're multiplying too many times in it. Multiply the first two terms together, come up with your answer. Multiply that by the next term, and that would be your finalized answer on that problem.